Have you ever wondered how IDs are generated across multiple servers and their uniqueness is ensured? If no, neither have I, until recently when I bumped into this problem myself. Hi, I'm Bahram, a software engineer, and today I will shed light on some different ID generating strategies, discuss their pros and cons, and at the end we'll implement our own distributed ID generator. First of all, let's talk about the importance of ID. IDs are used everywhere. In a sense, our IDs, they are association or reference to some specific item or object in that domain. In case of financial system, it can be a reference to some transaction, or in case of e-commerce, it can be a reference to some order. And handling ID generation is very important. And let's talk about what happens if IDs are not generated properly. It leads to a problem called ID collision. What happens if two customers let's talk about the common scenario when ID collision happens. Let's take the following situation in case of e-commerce. We have two customers, Bill and Bob, and they are by accident they were given the same IDs for their orders. They both have ID 123 and 123, and let's say that they are going to the pickup point to take their order. Bob comes to the pickup point and says, "Can you give my order with ID 123? As you can see in the pickup point, there is such order. Bob takes this order and he goes home or anywhere. He's happy that he got his order. And after some time, Bill comes to the same pickup point and says, "Can you give my order with ID 123? And as we know that Bob took that order and there is no more order with that ID. And there is no such order not found, and no one knows where that order went. And Bill becomes extremely angry. He's angry. He's unhappy. He's disappointed with that system because his order was lost. Where is my order? I don't think that your customer. I don't think that you want to face such kind of scenario while developing your application, and your customers will be unhappy with that. And that's why generating ID is properly is crucial. Let's talk about the different ID generating strategies. And first of all, let's talk about database sequences. Database sequences is the easiest and ready out of the box ready solution that we can implement right now, and it's efficient, it's reliable, but it has its drawbacks. What happens if the load to the database increases and one single server cannot handle all the requests? Ultimately, the database becomes the performance bottleneck, because single database cannot handle all the requests in cases of increased traffic, and or if data becomes too large, one single database cannot store all that data. And to overcome this issue, we apply the technique called database sharding. It's a technique where the data from the original database is distributed among several other databases called shards. And the problem here arises that it's really difficult to synchronize the sequence, because in case of single database, single table residing in one database, that table cannot generate sequence sequentially without not worrying about the data synchronization, because all the time it can increment by 1, by 2, etc. It's up to the step that you set at the deployment. But let's say that the original database was sharded into split into 5 shards, and now we have step equal to k. K in our case is 5 database shards, and each shard generates ID with that step. The first shard generates IDs 1, 6, 11. This shard with ID2 generates starting from 2, for example, to 712, and the step is 5. This solution actually works, but it's not perfect because it's not reliable. What happens if we delete or add new shard? And the whole logic breaks because the step becomes 6. And if the first generator, for example, not generator, ID, its step becomes 6, for example, if the next step becomes 6, 1 plus 6, it's already 7. That 7 is already taken by the shard number 2, and that's why it's the problem. And achieving data synchronization across multiple shards is very challenging, and that's why it's not the best solution, relying ID generation on the database in distributed systems. And next, let's talk about UIDs. UIDs is another way to identify objects uniquely. We can use UIDs to achieve high level of uniqueness, and we can run UIDs for many years, maybe thousands of years, because the probability of ID collision is so small that you can face ID collision for after running for thousands of years, and that's why UIDs are suited in many cases. However, they have their its own drawbacks. UIDs don't fit in cases where the ID should contain only numeric values, because UIDs contain letters and numbers as well, and that's why they don't fit in all the cases. Besides, they take to 128 bits to be stored, and this may not be the case when the ID size is constrained. And next, let's talk about the Snowflake. Snowflake is an algorithm that was developed and proposed by Twitter team, currently X.com. Their approach was so simple, and by surprise, it's amazing, because this approach fits in my case, and I dived deeper to understand, and this is so simple. Let's talk about this Snowflake, and to generate the unique ID across multiple servers, they consider the following factors. They consider time, server ID, and sequence ID, and the combination of all these 3 factors give us a unique ID across multiple servers. Let's start from time. As time never goes back, it goes only forward. All the time is unique, because time goes forward, it cannot go back, and there is no probability of the time collision, because it goes only forward. However, we cannot rely solely on time itself, because multiple servers have the same time, because the time is the same for multiple servers, and that's why if 5 servers, for example, call the current time for any given time, the time will be equal for them, and that's why there will be collision. The next factor to consider is server ID. As I said that several servers running at the same time, they might have the same time. However, since server ID is finite and defined at the runtime, they are unique and they are distinguishable. And that's why combination of server ID plus time plus server ID is unique from other servers running in a cluster. And that's why the combination of time plus server ID is unique. However, the combination of server time plus server ID doesn't ensure uniqueness in cases of high concurrency. And to ensure uniqueness in highly concurrent environment, we should consider the third factor. This is sequence ID. Sequence ID is the last piece of the puzzle to achieve uniqueness across multiple servers in distributed systems. I'll explain in a second, but before, let's talk about why time plus server ID doesn't guarantee us uniqueness. To demonstrate this, let's consider the following example. We have 5 instances of the same server running, and we have a load balancer that distributes load, and let's say that 5 requests are being handled. We have 5 requests coming to the load balancer, and the load balancer reroute all these requests to the corresponding servers. And let's say that time is the same for all these requests. It means that these requests are happening at the same time. And in this scenario, all these 5 servers receive only one request. Let's say that this is for this example, let's say that all these requests are being rerouted to exactly one server, and no server handles more than one request. It means in this case the ID is 1, 2, 3, 4, 5. These are IDs of the servers, and the ID being generated will be x plus 1, x plus 2, x plus 3, etc. In this case, this is okay. All these requests are unique because they are distinguishable by the server ID, and no server handles more than one request. But what happens when one server handles more than one request? What happens if more than 5 requests are being sent at the same time? Let's say that 10 requests are being sent. In this case, one server will handle more than one request at the same time. In this case, 2 requests will be handled by the same server. This is our server, and let's say that 2 requests are coming to the same server, and the server ID is 1. This is ID, and time is x. But how do we assign IDs for these requests? Will we assign x plus 1 and x plus 1 for all these 2 requests? In this case, we'll get ID collision. This is the problem, and this is where sequence ID is used. Sequence ID is used to ensure uniqueness inside one server when multiple requests are being handled inside the same server. In this case, this server will assign sequence ID. This is server ID. It will assign sequence IDs to these requests. This will be ID for request 1, and this will be for request 2. These are sequence ID. It will be sequence ID. Okay, well, sorry for my handwriting. I think it's clear that this is sequence ID. And in this case, no matter how many requests are being handled by the load balancer, by all the servers, all these requests will be assigned unique IDs across multiple servers, and this is why sequence ID is used. And as you can see, the combination of all these 3 factors, time plus server ID and sequence ID, they can ensure uniqueness. And the idea is pretty simple, and this is yet very efficient. I really like that. And let's recap. Time goes only forward, and it ensures uniqueness over time. Time now goes back, it's always unique, and this is guaranteed. It's across time. And server ID, ensures uniqueness across multiple servers in a cluster, and sequence ID is used to ensure uniqueness across the server ID, and these combinations ensure uniqueness. And this is how these algorithm works, and this is pretty simple, and this is very efficient. Next, let's talk about the memory limitation of this approach.